Hello, everyone. Thank you for joining me today. We're going to discuss another quantitative research method in communication research, and that method is an experiment. So let me share my screen with you. This is an exciting but very difficult method of collecting data in communication research. So I want to start this lecture by asking you, what do you understand an experiment is from the readings? Think about it for a moment. Have you ever experimented in life with anything? Have you ever tried to make a change in your daily routine just to see what would happen? I'm sure you have, and that is what experiments are about. What is like the basic thing that we could do when it comes to experimenting? How does the basic experimental design look like? So the main element of an experiment is to do something different and see what happens. For example, you could, if you're in your apartment and you decide to just stop watching television for 5 days and see whether that would affect your mood, whether that would make you do some other things. That could be considered an experiment. So if you watch television every day and you just decide, you know what, I'm not going to watch television for 5 days, and then you see yourself doing other things such as perhaps cooking or reading a book, then you could see that this change in behavior, you stop watching television, resulted in cooking more or reading books. Experiments focus on manipulating one variable to see what will happen to another variable as a result. The example that I mentioned, you basically manipulate with your television watching behavior. You decide not to watch television and see what will happen to your cooking habits or reading habits. When it comes to communication research, I was thinking about, or experiments in general, I was thinking about some examples that I could give you so you could understand what it means to conduct an experiment. So some example that you frequently hear about include, like, let's give this new medicine to rats and see what happens, and then we'll use that medication and test it on people. So that's a type of an experiment that they conduct in medical field. But when it comes to other fields, we could look at if exposure to alcohol advertising cause students to drink more. Is this a research question that would require an experiment in communication research? It definitely is. So what we need to understand when it comes to experiments is that there are independent and dependent variable. Independent variable is the variable you're manipulating with. So if you ask a question such as, does exposure to alcohol advertising cause students to drink more? Exposure to alcohol advertising is your independent variable. Drinking is your dependent variable. Why? Because we are manipulating with independent variable and to see whether it would cause a certain outcome. And that outcome, in that case, the dependent variable, is drinking. So this could be an example of communication research because we are talking about advertising, and advertising presents this form of communicating a message to people. So again, when we look at like the previous example, watching television and cooking, so in that case, what do you think would be an independent variable and what would be dependent variable? So if you think that watching television less would result in cooking more at home, what would you consider to be an independent and what would be a dependent variable? Independent variable, so you're manipulating with your TV watching habits, which means that that is an independent variable, and the outcome variable, the dependent variable, is cooking. Other examples of potential experiments include, how do people react to the discounts they get in their mailbox? Could this be related to communication research? Absolutely, yes. So we could just supply people with discount leaflets and see if that would affect their purchase habits. Another example is, does heavy use of social media cause a change in the frequency of interpersonal communication? So for example, in this case, the independent variable would be social media use. And the dependent variable would be frequency of interpersonal communication. Why? Because we want to see if we, let's say, use social media all the time. For instance, if we spend 10 hours today on social media, we might be reluctant to engage with people face to face. So for that reason, our heavy social media use could just have an impact on us, because we feel that we had that social interaction with people online. So why do we need to go out to a park and just take a walk with a friend? So that basically reduces your communication with people. Or when we talk about frequency of interpersonal communication, it could be basically that you, let's say, expose yourself to social media content, you read what other people post, so you feel like that's your form of social engagement, so you don't need to engage in any interaction with other people. Another example is, which ads about vaccines are most persuasive. So we could expose people to diverse ads about COVID-19 vaccines and see in which case, which instances would they feel that after seeing that ad, they would get a shot as soon as possible. So these are just some examples that I listed, and also when it comes to an experimental design, there's so many different types, and I'm sure you read this textbook chapter and learn about them, and they really seem complex. And I'll discuss later in the lecture why there are certain challenges in performing an experiment. But if you want to do something basic, to design a basic experiment, the one thing that you could do is simply set up two groups. Let's say we have two groups of students, and then for example, in the case of watching television, you could simply put in one group students who simply continued watching television. And so there is no change in their behavior. So one group of students will watch television, keep watching television as much as they used to watch before this experiment started. And then another group would be exposed to this treatment variable, which means that they would be asked to stop watching television, and because we want to see if that will result in more frequent cooking at home. So they would be exposed to treatment. They would simply be asked not to watch television for 5 days, for example, and then we would see what happens if they stop watching television. So this is a basic experimental design, and then we would look at if these two groups differ. If, for instance, group B started doing something else because they stopped watching television, but what is it that they started doing? And is there any change in behavior? We want to see if there's any change in their behavior and if these groups differ. So if people in group B actually didn't start doing anything else because they stopped watching television, we would make a conclusion that basically reducing not watching television doesn't really make people do other things that they were not engaged in. But I'm not sure that would be the case, but I'm just giving you an example. We want to see if this treatment had any impact on group B and their behavior at home. There are many, as I mentioned, types of design. One of them is ex post facto design. What does this mean? We basically want to design an experiment after we observed what happened as an outcome of some other variable. Let's see, I suddenly noticed that students would watch, let me think of an example that I know that there was an example in the textbook that was really good, but I'm trying to think of a related example that could help you also better understand this. So let's see. I suddenly noticed that students would watch my video lectures 2 times, and I want to see, but I'm not sure what caused this. So let me just assume that students are actually determined to decided to conduct a research study, a strong research study, and they simply feel that they need to rewatch video lectures just to make sure that they understood these concepts well. So I'm not, I didn't have any impact on their decision to conduct this research product. And I realized that something happened. And this is the reason why they suddenly started watching my video lectures 2 times. So in this case, I didn't manipulate any condition. I just want to do an investigation after this fact has occurred. So I did learn that you decided suddenly to do this research project and perhaps publish it in a scholarly journal. So you're determined to do a good job. And for that reason, you feel that you need to watch video lectures even 2 times to make sure that you comprehend the material very well. And I learned about this fact, and that is the reason why I decided to do an experiment and to see if this is actually to observe what happened, if this is actually the reason why I started watching my video lectures more frequently. And another example is that a professor can investigate what caused some students to perform better on the test than others. Did they, let's see, they learned that these students perhaps read the textbook and other students did not. So a professor wants to investigate what caused them to perform better. In this case, the selection of participants is not random because you're not randomly selecting people. Something happened and then you're just observing the consequences of what happened. Another type of an experiment is field experiment. This experiment is a natural, and that is its main advantage versus an experiment that happens in artificial conditions. In this case, a researcher designs an experiment and selects participants for different conditions. An example is that this person, like we could now compare field experiment with ex post facto experiment. So in this case, they would actually provide a textbook for one group of students and ask them to read the textbook prior to the test, while other group will not read the textbook. So you see how they're affected of manipulating this condition. In case of ex post facto design, there is this assumption that the students who read the textbook actually scored better on the test. But in this case, we want to make sure that is really the reason. So for that reason, the professor provides a textbook for one group of students and another group of students does not receive the textbook. And then after he collects data from both groups of students, the researcher could inspect it and see based on the test scores which group performed better. So was it the group that used the textbook prior to the test, or was it the group that didn't use the textbook? So they will basically determine whether this group that used the textbook scored better or not. In experiments, when we conduct an experiment, especially when we're conducting an experiment in artificial setting, which is usually the case, we want to design an experiment to control certain things. So what does it mean designing for control? Control means that we want to remove all other possible variables from the experimental design to make sure that only the treatment variable is causing the changes. So let me go back to my example from the beginning about watching television. What if something else plays a part in people's decision to cook more? It could be reducing not just the amount of time that they spend watching television, but also the amount of time they spend engaging with social media, for example. Control groups are those groups that are not exposed to any experimental variables. So you probably heard about this before. What does it mean in case of a COVID vaccine? For instance, there is a group that is experimental group. So that group receives a dose of COVID-19 vaccine, and then another group does not receive it. That group is control group. So it is not exposed to any experimental variable. But we then want to compare these two groups, control group and experimental group, and see whether the treatment has any effect of that experimental group. Let's take a look at some examples of experiments. So I was just thinking about how to explain this control thing in an experiment. So one example is you want to test if outside noise impacts students' comprehension of science content. And how do we control? How do we make sure that noise is what really impacts their comprehension of content? Let's say if they're exposed to more noise, they're less likely to understand the content. So we could make that assumption. In this case, an independent variable, what is actually, if you think about it, what is the independent variable? It's the variable that we manipulate. So in this case, where a variable that we manipulate is outside noise. So in one group, there will be students who are not exposed to outside noise, and that group is what? The group of students who are not exposed to this noise, that group is experimental or control group? It is a control group. And another group, the experimental group, is the group that is exposed to this noise. So we are manipulating with the noise. Dependent variable in this case is comprehension, because we want to see if that noise affects their comprehension of the material, of the science content. Control variables. So what is it that we should control for? We want to control for room temperature. So every student in this group needs, in these two groups, every student needs to be exposed to the same room temperature, and they should be exposed to the same amount of light in the room, because we want to make sure that there are no other things that are affecting their reading comprehension. So other conditions need to be the same. Why? Because if temperature differs, if some students feel too hot or too cold, that could affect their comprehension along with the noise, or that could affect their comprehension more than the noise itself. So we need to make sure that we are really controlling for other conditions, that everyone is exposed to the same room temperature, everyone has the same amount of light in the room. And another important component of this experimental design is random assignment of participants. So we're not going to go around and say, okay, these 10 students should go to this group, these 10 students to that group, and we just decide, or we actually ask around people who wants to be in which group. No, we're going to throw dice, or we're going to use a random number generator, create two lists of students, and just randomly assign them to these two groups. Let's take a look at some examples of designing for control. What are some types of experiments that utilize this? Those include two groups, pre-test, post-test design. In this case, both groups' scores on test, for example, are measured before and after one group has been exposed to a specific condition. So what does it mean? We want to give students we want to test students' knowledge before we give them the textbook to read, and then we want to test their knowledge again. We want to see if actually their comprehension of the material is different now, if their test scores are higher after they read the textbook chapter about the textbook. So in this case, the control group doesn't receive the textbook, and the experimental group receives the textbook, reads the textbook, and then they compare scores of both groups and see whether there is a difference between these two groups with respect to their test scores. In another case, with two groups random assignment pre-test and post-test, group members are not volunteering to be in one group or another. They're just being selected randomly. So in the first example, I could just say, okay, who would like to be in the control group? Who would like to be in the experimental group? But in this different scenario, I would just assign people randomly to different groups, and then to make sure that I could actually generalize this data. There are other examples of control when it comes to experimental design, and that is the Solomon for group design. This is a bit more complex to design and understand. What does it mean to have 4 groups in your experimental design? So just think of this example about taking a test in, let's say, biology, and then reading the textbook, and then taking the test again and see if you are able to obtain higher scores. So how do these 4 groups differ with respect to the treatment they're exposed to, whether they're what is their role in the experiment, what is it that they're supposed to do in experiments? So there is first random assignment. So there is one group that is exposed to both pre-testing and post-testing and subject to experimental variable. This is the test group. So this is the group that is actually going to read the textbook between this pre-testing and post-testing stage. Then we have random assignment that involves pre-testing and post-testing, not subject to experimental variable. They don't read the textbook. So this is the control group. And then the third group, people in this group are also randomly assigned. There is post-testing only. They're subject to experimental variables. So their knowledge is not being tested before they get the textbook. And then after reading the textbook, they basically take the test. So there is post-testing involved, and random assignment, but there is no pre-testing involved in this case. And this group is basically checking if the pre-test is not influencing results. And finally, random assignment, post-testing, this group only engages in post-testing, but this group is not subject to experimental variable. And this group is basically checking if nothing other than the pre-test and the experiment variable is influencing results. So It looks complex, but with the nice strict design, this could be performed, and we could collect some important data and make generalizations based on the data collected. Other types of design include the factorial design. This type of design manipulates two or more variables. So these designs that we looked at before involve only one variable, only one independent variable. But we could, for instance, create a design when we manipulate two or more variables. In the case of um, scientific context comprehension, we could actually manipulate both the noise and room temperature. Another type of design is between subjects design. This is an experiment in which one person participates in only one set of conditions. So that person could be the control group or an experimental group. And within subject design is an experiment in which one person is exposed to more than one experimental condition. So not only, the person could be exposed to two or three experimental conditions. Now, let's take a look at advantages and disadvantages of experiments. One of the key advantages is determining causal relationships. So this is the this is the method that actually allows us to determine cause and effect. Are we able to do that with surveys? We're actually not. There is one example where we can determine causal relationship, but we can't do it with other forms of, with other methods. This is like the method that we use to see how one variable causes another, where we can determine, where we can examine cause and effect. We could also determine the direction of causality. So in this case, we could say that as the amount of time spent watching television decreases, the amount of time we spend in the kitchen increases. So we kind of know the direction of this causality. And also another advantage is that we could demonstrate the influence of one variable or another. And we can have control over research conditions. What are some disadvantages of this research method? So the first one is that the conditions are artificial, especially if we look at the Solomon design, and then the design where you have pre-test and post-test, and then you expose people to certain condition. It really doesn't happen like that in the real world. So we cannot really create 100% natural conditions when we're conducting an experiment. Validity of an experiment could be also questionable, and I'll discuss that in more detail. And also experiments could involve certain ethical issues such as deception. They may require a large number of people, and this is especially the case in the medical field. And how are you gonna convince people to participate in the experiment? How are you gonna recruit them? There are certain ethical issues that come with this type of research method. Also, conducting an experiment could be time consuming. I know cases that I learned about from my friends where they actually, where things went wrong, so they had to repeat the experiment. And then are you going to recruit the same groups of people? Are you going to look for new people because the experiment was not successful with this group? So it could be really time consuming. But the actually the part that is really time consuming is when you're setting up an experiment. You really need to look and think in depth about it and make sure that you're controlling for multiple conditions, that there are no other things interfering in your experiment. So it is very complicated to design a solid experiment, but Once you design a solid experiment, then data collection could happen literally in a day, and you just need to make sure that nothing will go wrong. And after you collect data, you'll simply analyze it. Like, also one more thing that I wanted to mention, I mentioned the medical field and how you basically can just test the medicine and collect results afterward. In communication research, what we do, we usually there is a questionnaire involved. So we need to ask multiple questions before we expose people to a specific condition. And then we ask them questions again. So we do pre-test and post-test, and basically we collect, this is what we usually do. So we collect information from them, and then we analyze that data. So a questionnaire is involved in this case as well. So if you know how to set up solid, strong, readable, understandable survey questions, question that would be incorporated in your questionnaire, that is a really, really strong advantage for you. Let's look at the validity issues when it comes to experiments. So there is an internal validity problem. What does it mean? There are certain spurious relationships. So these relationships are not genuine. They really happen by chance. Another thing is selection bias. So it is the best thing to do is simply to randomly assign people to groups to make sure that you can generalize the data collected. Attrition is another problem. People simply drop out of studies, and then repeated testing. So if you repeat testing, people have more knowledge about it. They understand what the experiment is about, so they are likely to produce different scores. Another issue is external validity. So that means that people, the experimental situation itself are artificial. So that could mean that people are likely to behave differently than if they were in a natural setting. And there's the so-called Hawthorne effect, which means that we are aware as experiment participants that we are exposed to this treatment, that we are participating in this experimental conditions, that we're participating in this project. And because we are aware of that, we change our behavior. Suddenly, we're more focused in case of the example with the textbook, we are now more really focused on what we are reading because we want to have high scores on the test. So this is my reference list. I would just like to mention some key concepts. I didn't list this on any of the slides, but some of the key concepts in case of experiments would be independent variable, dependent variable, control groups, experimental group, control variable, and what else? Reliability, of course, and validity. That is critical in every research study that involves quantitative methods. And this is all that I had for you for today. I know that this is a complex topic, but I hope you understood that you have now some understanding of what it means to conduct an experiment. Thank you very much and have a great week.